Okay, we're going to start off with a little bit of reviews. Some of you had a little bit of trouble with our finding the distance between 2 points. So I'm on page M465. This is where you were working yesterday. And you may have these, you may not. I'm just going to do a few more examples because what we need to make sure that we're doing is writing the absolute value equation. Okay. Now, when they're drawn on here, we can just count them. Okay. And that's a great way to check yourself. But we need to also understand the absolute value equation here because eventually, there may not be that good. So we may not be able to count. So I'm looking at B and F. Okay. I can see that for B and F, the Y value would be the same. It would be -9. Okay. So I'm really just concerned with the X value, or I'm sorry, the Y value. So that would be 8. And let me move myself here. Let's see, F would be down here at -7. Now, if that's confusing, you can always write the coordinates, -9, 8, and this one is -9, -7. Remember, as I did yesterday, -9 is the same, so we're ignoring that, and we're looking at the 8 and the 7. So this is where we have to think about they are opposite signs, which means one is a positive number, one is a negative number. So we add their absolute values together to find the distance. Absolute value is the distance from 0. That's all it is. And we always measure distance in a positive way. So the absolute value of 8 is 8. The absolute value of -7 is 7. So we know those are 15 units away from each other. Okay. And if I were to count this out, it would be 15. Okay. I am going to do another one. Write an absolute value equation and calculate the distance from point D. Okay. So I'm going to get the coordinates for point D. I know the X is first. I have to go over here to -3. And then my Y is going to be a 4. So comparing that to the one that they gave me here, I can see that the -3's are the same. Okay, so I'm going to ignore them. There's no distance between the same number. So I'm going to write the absolute value. I can see that -5 and the 4 have opposite signs. One's negative, one's positive. That tells me I want to add their distances together. The absolute value of -5 is 5. Absolute value of 4 is 4. Adding those together is 9. Okay. So when you hear me talking about the signs being different on the practice worksheet, there are 3 examples where the sign is the same. Let me run through an example. Let's say I have, we'll call this W down here. Okay. And I want to measure the distance from C. So C is 4, -5. My W that I drew in there is 8, -5. Okay. So the -5s are the same. We're ignoring those. Here are the 2 numbers of interest here. If you'll notice, they are both positive. So when I look at where C and W are located, they are on the same side of the axis. Okay. This is the Y axis, up and down. The x-axis is left and right. These 2 points, to connect them, are not crossing over one of those axes. So that means they are the same sign, which means we're going to simply subtract to get their distance. And I can check myself. 1, 2, 3, 4. Neither one of them go to 0. So I would not be utilizing the absolute value here. Okay. I hope that kind of clears that up and helps you. I'm going to do one more here and then I'm going to move on to the rest of our lesson. Absolute value equation. So I can see here that my -4's are the same, so I'm ignoring them. Okay. I have a negative number and then a positive number. So I know that I'm going to take the absolute value of -7. I'm going to add it to the absolute value of 3. I want to get the distance. The distance -7 is from 0 is 7. The distance 3 is from 0 is 3. I add those numbers together and I get 10. Okay. Now, our next target, our last target in this section, is going to be drawing shapes on the Cartesian coordinate plane. Now, Cartesian coordinate plane, it's no different than the coordinate plane that they're used to that we've been graphing on. Cartesian is just its fancy name. It's like the last name of the guy who invented it or something. Okay. So just know that's its fancy name. So graph the points and connect to form a polygon. So we would have connect these and then be able to say, well, what kind of shape is it? We're on page M475. So 1, -2, -5, -2, 1, +3, -5, 3. Okay, I'm going to grab a different color here. I'm connecting. And if you want to get a ruler for this, as you can see, mine aren't exactly straight, but I can tell by looking at that, I have made a rectangle. Okay, pretty simple. Okay, now let's see. That's the same thing. The next part of this, let's try this one. M476, -2, 5, 3, -3, -2, -3, 5, 2. Connect. That's straight, that's straight, that's straight, that's straight. Ooh, that's kind of a crazy one. Look, here's the answer. Okay, we're not going to worry about finding the area of the polygon, but we want to know what kind of shape that is. Okay, so I want you to think about that. Okay, it's got 4 sides. Okay, they're not equal sides, so it's not a square, it's not a rectangle. Okay, so I want you to think about what that is and see if you can come up with an answer. When you have a guess, let me know. The last thing that we have to worry about here is completing a polygon. Okay, so they're going to give us some of the points, and then we have to finish the shape. Okay, so we have A and B here. I'm on page M476. Okay, it says plot and label points C and D so that squares are formed. Okay, so this is where we have to really kind of, I'm going to see if I can zoom in on this. I have to count and see how long is this side. 1, 2, 3, 4, 5, 6. So we kind of have to know the distance because what do we know about a square? All the sides have to be the same. So I'm going to count out 6. 1, 2, 3, 4, 5, 6. I know I need a point there, and I know I need a point here. A, B, C, D. So the coordinates of C would be 4, -2. D would be 4, 4. And they form a square. Okay. Now there's not a whole lot of practice on this in the book, I don't think. Let's skip here to page M477. Okay, and I know our video is probably getting close on time. So let's see what we're supposed to make here. A parallelogram with the height of 4. Okay, so I'm going to zoom in here. I know that the height needs to be 1, 2, 3, 4. So the top of my parallelogram needs to be here. Parallelograms have slanted sides, but they're equal. So I'm just going to pick and say 1, 2, and then I'm going to move over 2. But I have to keep this same pattern here. Up, over 2. Okay, then I connect. Looks like a pretty good parallelogram. Now I just have to say A, B, C, D, and plot the points. Okay, so this one is at 8, 2, And this one is at -2, 2. Okay. Let's see if there's another one you guys can try on your own. Whoop, way too big. Okay. Page M477, I want you to try this when you're going to make a triangle. They want it to be a right triangle. I'll remind you what a right triangle is. There should be a 90-degree angle. That means it goes straight up and straight down. Okay, so give it a try. Let me see what you come up with. Okay, and I will find some extra practice. Good luck.